Alrighty. Setup's gonna be a little bit scuffed, don't mind me. I'm in the process of disassembling my setup, so all my stuff is shuffled around from where it usually is. Let's see, is this the right display? It is. Okay, cool. There we go. There's my side monitor. Looks a little bit washed out, but hopefully that's fine. I need to find a way to get chat over on the side of the window. Can I just drag that over? Is OBS gonna yell at me? Probably. Okay, I'm just gonna stick that over there so I can see it without having to look all the way over to that side of the desk. Cool. Hello, hello, hello. Hi, Yahazu. Hi, Oshu. How y'all doing? Gameboy programming. Haven't done a programming stream in a little while, so that's exciting. I'm thinking, tired's understandable. Same. Thinking I want to try to code like Snake, like the classic, like you move around and you grab items, fruit or whatever, to become longer, and you have to not crash into anything. I'm gonna try coding that on the Game Boy. I don't know if I know the Game Boy well enough to be able to do that, but I'm hoping I do, so I guess we'll find out. So I've taken the liberty of getting some of the setup going already. I've got all my tools and base file put together, so we don't have to start all the way from scratch. But currently all I have in terms of functionality is I've got a sprite sheet. The Game Boy only has 4 colors. Pre-decided colors, the shades of green. But I got an empty sprite sheet that I'll be able to draw in sprites onto. And I have that all set up so that I get loaded into the Game Boy. So this is my Game Boy emulator down here. I wonder if I can make that any bigger. Probably. Window size, that's the one. 3x3. That looks better. Can't even really see anything, but you can see right here this VRAM viewer window here has all the tiles that I'm loading in here. So the second one here has these 4 colored dots from this tile sheet right here. Actually, those reversed. They are. That's going to be confusing. Let me see if I can fix that. Can I rearrange these? Rearrange color map. That's the one. Does that pop up with a window or something? It does. Okay. Gonna rearrange these so it matches what's on the actual Game Boy. There we go. Export that. There we go. Okay, now it matches. So I got this tile here and it's loading onto the Game Boy. You can see this section of other tiles on here. These are from the Nintendo logo. So the Game Boy like scrolls the Nintendo logo and displays that. Which I think I can even show off if I just disable this. Yeah, so the Game Boy starts off by loading this Nintendo logo into here. And that's what's getting displayed there in the center of the screen. And then when I load my tiles in, it's just replacing that data, but it's not actually clearing out the screen. So it's still trying to display all those Nintendo tiles here. I just replaced those tiles with a blank tile. So that's fun. But yeah, so I got absolutely no game functionality coded in yet. So that's primarily where we're going to work on, I think. So, change Nintendo to by Hawk Labs. theoretically, but actually, it's kind of funny. So that Nintendo logo is actually incredibly important. That is how they check to see if it's a legitimate Nintendo game cartridge or not. So if you don't have that exact Nintendo logo loaded in when your game starts, then the Game Boy will crash because it thinks that it's a invalid memory card. And they did that to prevent piracy, theoretically. They didn't want anyone to be able to replace the Nintendo logo. And because the Nintendo logo is copyrighted, hi Lowell, Boyo indeed. They're like, so if you include the Nintendo logo in your cartridge and you're not Nintendo, then that's copyright infringement, so we can sue you. I don't know if they ever actually managed to sue anyone over it, but that was the idea. Yeah, so we're coding for the original Game Boy, the gray brick Game Boy. I can pull up a picture. I don't have an actual physical Game Boy on me, but theoretically, we're writing for an emulator that works just like the real one. Yeah, this thing. The original Nintendo dot matrix game console. I don't have a physical Game Boy sitting next to me because they're really freaking expensive. Hundreds of dollars, and they don't run that well. I'm not gonna lie. So instead, we're running it on an emulator. So this is a highly accurate emulator, and theoretically, if I was able to put my game code here on a cartridge, it would run on an actual Game Boy. So that's fun. Game on that boy, that's what we're doing, Sugi. Welcome in, welcome in. Thanks for the free subscription. 3 months in advance. I don't think I've ever seen that message formatted that way before. That's interesting. Much appreciated. Thank you, Sugi. Game goes binted. Exactly. I need to remember that I've got a chat window over here so I don't have to look all the way over onto that monitor. My desk is a mess right now, but it's fine. So yeah, I started scaffolding the project already, so we've got our code file here, our assembly code. It doesn't do much. Currently, it's just doing some initial setup. We disable the audio chip because we'll deal with audio later. Usually about 3 month subs, and it's also the first time I've seen it worded like that. Yeah, it's weird. I appreciate that it's that it clarifies that though. Like, if you buy 3 months worth, and it's good to know that compared to the notification sounding like it's just 1 month. But yeah. So we clear out the audio, and then we wait for the V blank period. I can explain that because that's pretty important to how the Game Boy works. And then we turn off the display. We copy all of the tiles I've created into the Game Boy's memory. Turn the display back on, set color palettes, and that's all we're doing so far. Before it was hard because you had Nick on a 6 month sub and thought it was just sub for 6 months. Yeah, it makes sense. You had Nick buy a 6 month sub. Gotcha. Yeah, that makes sense. Well, they're clear things up then. It's useful. So yeah, I got this this tile set. It's currently empty. But it's just a PNG file that gets translated into Game Boy code by some of the command line tools that I have installed. And that gets loaded into memory. First you thought Crafty was green, and you can't spell by. And large tired. All good. You are allowed to be tired, I would say. But yeah. So the game loads the Nintendo logo, and now we're replacing all the tiles with our own tiles. So it's still trying to show the Nintendo logo here, but we just overridden the tile data. So it looks like this. So yeah, now we have to actually like make the game. The hard part. Yeah, just to explain a little bit about how the Game Boy works and why this is going to be kind of tricky to code. Let me pull up some pages in the documentation. Okay, so you can think of the Game Boy's display like a typewriter, where it goes across the screen line by line, pixel by pixel, drawing pixels. So there are 144 lines of pixels on the display, and 160 wide. This looks kind of squarish, but it's 144 pixels tall, 160 pixels wide. Step 3 profit, exactly. Step 1, draw the Nintendo logo. Step 2, code the rest of the game. Yep. Hi, Kitsu. Welcome in. Congratulations again. I don't know if I posted, actually, now that I think about it. I messaged No. I can't keep track. I'm so busy today. I'm sorry. Game thinking. I'm currently thinking Snake, because I know how to code the logic for Snake, I think. Or at least I know it well enough to be able to translate it into Game Boy code. I meant to DM you, and I guess I just didn't and thought I did. My brain is everywhere today. My bedroom is currently... I've got half a bed frame lying on the floor. My mattress is against the wall. Sorry, yep. But love you guys. Appreciate you all. Yep. My brain is very frazzled. Tomorrow is moving day, so I'm stressed, but it'll be fine afterwards. So yeah, coding for the Game Boy. So, as I was saying, 160 pixels wide is the Game Boy screen, 144 pixels tall. So yeah, I'm moving to a new apartment. Well, technically I'm moving to my family's, my parents' house for like 3 weeks and then moving to a new apartment because the logistics ended up being complicated, but it's fine. I'll figure it out. But yeah, I'm moving closer to my parents because current economic situation in the US is a mess, and I want to be prepared in case my parents need help or I need help, basically. Yeah, so that's fun. So yeah, anyway, I keep getting distracted. So the Game Boy's display. There's a bunch of technical information here, but the important part you need to understand is... Well, you don't need to understand it, but you know, if you want to understand it, I think it's interesting stuff. The display is like a typewriter. It goes from left to right, drawing pixels to the screen. Left to right, and then top to bottom. So it'll start in the top left corner, and it'll write that whole row of pixels onto the screen. Then it'll go to the next row, write all those pixels. So everything that it's doing while it's drawing these pixels prevents us from doing anything with screen data. While the display is drawing things, we can't do much, basically, in terms of our game code. So every line of pixels, it spends a certain amount of time drawing sprites or drawing pixels, and then there's something called a horizontal blank period, or H-blank period, and that's a short period of time here at the end of each line where we are allowed to write our own code. And there's only enough time for a couple of commands for our code to run during that time. And it goes through 144 lines of pixels, because that's how many lines of pixels are on the actual Game Boy display. And then there are 10 fake lines that aren't real, but thing pauses for that long. And that's called the vertical blank period. I guess it's because it's like blank as in it's not drawing actual pixels, it's drawing nothing. So that's why they call it blank. So we got a little bit more time here where it's doing these 10 fake lines of pixels after it's done drawing the screen to do stuff. But these short little gaps every line, and then this slightly longer gap after it's done drawing the screen, those are the only opportunities we have to run any code on the Game Boy, which is very limiting. Happy Friday indeed. It is a very eventful Friday. So, a lot of our code is going to revolve around trying to make sure our code only runs during these vertical blank sections, because that's where it's not going to break the Game Boy to run things. So like, for example, here in my setup code, in order to copy our tile sets, all this tile data that I've got set up, all our graphics, into the Game Boy's memory, we have to turn off the display, and we can only turn off the display during that V-blank period, so we have to wait for it, having it set to run only on V-blanks exactly. So I got all this code to wait until a V-blank happens, quickly turn off the display, copy our data, and then turn the display back on. In fact, actually, I think, does this have to happen before or after? I don't think it matters. I think you're allowed to modify these during V-blank. So that should be okay. Yeah, so our gameplay loop, I'm pretty much gonna just try to set it up so that we're only running code during the V-blanks, which is only a small fraction of when the Game Boy is actually running stuff. But that's the simplest way to do things. I'm sure that went over everyone's heads, but still, I feel the need to try to explain. Okay, so why don't we start by making some pixels? That's the fun part, really. Let's draw the tiles that we're gonna need for our snake. But Nintendo simply create multi-threading. Yeah, the Game Boy, I think, predates multi-threading as a concept, pretty much. Some of the later Nintendo well, that's not entirely true, actually. In fact, part of the problem is there are multiple processors clocking things in parallel on the Game Boy. The display, primitive graphics card, as it were, is its own chip that is writing to the screen at the same time that the regular CPU, the regular processor, is trying to do operations. So really the whole Game Boy is parallel. Just not in a way that you can safely do it from regular processor code. Hawkbud nerd here, exactly. That's me. So yeah. I'm not very good at art. But I guess we'll need a snake head that is going in all four directions, and then we'll need a snake body section. And we'll start there, and then we'll make it look better as we go. So let's say if we're doing a snake head, I don't know what snakes look like. Imagine he's just got an eye there. Maybe I could do fangs. That kind of looks terrible. How can I make this look more mouth-like? Maybe like that? And we can use a different color for the fangs. That does look really terrible. Some kind of monster. But sure, this is a weird alien snake thing. The Game Boy doesn't have a lot of pixels. So we got it facing left. I'm gonna make it face right. Then we also need up and down. Probably what I should have done is done it top down instead of side view. But I also don't know what a snake looks like from that angle either. Up and down and all around, exactly. You get it. There we go. Good enough, so that's like the snake going upward. And that's it going downward. And then we need body segments. So currently it looks like their body's like 4 pixels wide. Yeah. So we can do something here where we do 4 pixels on either side, so we'll be smooth. And then we can kind of have the body sway a little bit. Or wiggle a little bit. Just for fun. The nice thing about this is this will work for left or right. That doesn't matter for the direction, because it'll loop the same in either direction. Same for vertical. And then I'm not going to deal with the tail for now, but that is something we're going to have to add eventually. But that is going to require a little bit more effort, so we will save that for later. Same with corners. We'll do corners later. But let's do an apple. Or fruit or whatever. And its simplest, those are just circles. And then we can do it a different color to distinguish it from the snake. Oh. And then if we want it to be an apple, maybe we can shape it a little bit better. So apples kind of have this like divot thing going on. Oh. Hard edge eraser, there we go. It's a very white apple. And the apple stem. And then like a leaf. I don't know. Maybe if the stem was on the side like that. This is too much of a mess. I'll just leave it as a circle. That's fine. Still gets the idea across. Okay. Export that. Rebuild the code. And boom, look at that. Our sprites are in game already. That's exciting. So we can see them there in the Game Boy's memory, and they're being displayed where the Nintendo logo is supposed to be. Alright, so I think first things first though, I should clear out where the Nintendo logo is, so that's not showing anymore. So let me add a loop to clear out the tile map. And let me remember where that memory is by looking at the documentation. Tile maps. Actually, I guess, and this should show it as well. Background map. So this is the tile map that starts at 9800. Yeah, okay, so we have the tile map at 9800, although we actually only need to clear out these two rows, so maybe that'll be easier to do. So that's the 9900. Then we need to clear out to 9940. So we need to clear out those 64 tiles. That makes sense. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so there's 32 tiles in this row here. So we want to clear out these two rows. So that's 32 times 2, 64 tiles. We want to reset them to 0. Hello, Summit. Welcome in. Ah, YouTube chatter. Don't see very many of those. Welcome in. Okay. Yeah. So we want to clear out the tile map. So all these tiles where the Nintendo logo was are gone. So we're going to do a loop. So we're going to point our HL register. How's it going? We just started, more or less. But the goal is to code the game Snake in Game Boy assembly code. I don't have an actual like Game Boy with a blank cartridge, but theoretically, this code would run on an actual Game Boy, hopefully. How many registers does the Game Boy have? Glad you asked. I don't know if they're visible on screen here. But the Game Boy does not have very many registers at all. Curious about making that work? Yeah, it is very possible to put emulated games like these on physical cartridges. They make they're called flash carts. But basically, it's an SD card that acts like a Game Boy cartridge. It like has a chip inside that'll do all the mapping to read the data off an SD card, and put it into the pins that the Game Boy's expecting. They're pretty cool, but they're also really expensive because they're basically made by hand. So you kind of just have to request someone who knows how to do it for you and wait for them to make a batch. But it's a whole thing. There's a lot of people that do it. I don't know if it listed in here. Maybe it does. Yeah, so the Game Boy is mostly an 8-bit machine. It's got one important register, the A register, which almost all math operations work on. Only the A register. And then there's some generic registers B, C, D, E, and H, L. And those can be sort of treated as 16-bit registers by a few instructions, but they're just doing 8-bit math under the hood and combining the two. Yeah, mostly. You teach me how to code? Unfortunately, I'm not very good at doing that. I've tried teaching people in the past. I'm not a very good code instructor. But there's a lot of resources out there online. I highly recommend just Googling coding tutorials, coding video courses and that sort of thing. There's plenty of free materials out there. I learned like decades ago, so what I know is pretty outdated. But basically what this means is we've got a few, they're called registers, but basically they're little, you can think of them as little buckets that hold a single value each. And then we can do math operations or copy the values from these buckets around to other places. We've got the A register, which almost all math has to be done on the A register. There aren't instructions to do them on the others. Then we've got B, C, D, E, and H, L, which are like other generic buckets that we can temporarily hold values in before doing math with them in the A register. Not a whole lot of scratch space to work with, basically. So you're going to see a lot of the A register in here. I'm going to highlight it right here. So you can see like I'm doing a lot of XORs on the A register. I'm incrementing the A register, increasing by 1. Copying the value from the B register into the A register. Doing a logical OR between the A and C registers, that sort of thing. So most operations are going to involve the A register in some way. So anyway, yeah, sorry, Summit. Don't think I can help you with that. Good luck. So, I don't know if anyone's going to be able to follow along, but I do enjoy this little shortcut here. So, normally if we wanted to set A to 0, we'd say something like this. Load the value 0 into register A. But that's actually not the most efficient way to reset A to 0. Because the 0 here actually takes a byte of memory to hold the 0 value and then put it into the A value. So we actually save space by doing it this way. So bitwise, it's very similar to 6502, yeah. 6502 has more memory addressing modes than the Game Boy does. The Game Boy is using a stripped down Z80 processor. It's got more registers than the 6502, but it's less flexible in how it can use them, which is interesting. 6502 has fewer scratch registers. It doesn't have like the BCDE temporary registers to hold values, but it's much faster accessing memory. So it tends to rely a lot more on doing like indirect memory accesses to quickly operate on values instead of storing them in registers directly. They're both pretty cool. The NES, Nintendo Entertainment System, uses 6502, but the Game Boy is Z80-like. Technically, it's not a Z80. There's a bunch of instructions that it doesn't have. But yeah, so the bitwise XOR is pretty cool. So, say we have a binary value made of 1s and 0s like this. Which I'll just do 4 bits. That's easier to look at. And then we got the second value here. So a bitwise XOR what it does is it says if a bit is 1 in one of the values, but not both of the values, then set it to 1 in the result. But if it's 0 in both or 1 in both, then set it to 0. So since this first bit here is a 1 in both, then it'll be 0 because they're the same. 0 and 0 are both the same, so that's 0 again. 1 and 0 are not the same, so that's a 1. 0 and 1 are not the same, so that's a 1. It's a very useful operation, but what's fun is when you use it on the same value. Like say you do an XOR on A with itself. Well, every single bit is now the same. 1 and 1 are the same, 0 and 0 are the same. So it'll always be 0 for every bit, because the bits are the same in both places. So by doing a XOR AA, it effectively is the same as resetting A to 0. But it takes up less space because you don't have to explicitly say 0. So when you're programming on really, really old limited hardware like the Game Boy, you have to be able to do tricks like that to squeeze out every little bit of performance, because it adds up very quickly. Kind of miss when game companies design their own chips. It's just cool. Yeah. Very much so. I love reading about how like the audio processors and graphics card picture chips are coded on these kinds of hardware. Game consoles, yeah, really cool. And to do a lot of tricks to do exactly what they wanted to be able to do with hardware in as few clock cycles as possible, and with as few transistors as possible, logic gates. So anyway, so we're going to clear out the tile map. We're going to clear out 40 bytes in hex, so 64 tiles, starting at here in the tile map. So we're using the HL register. That is one of the special case registers. There are some 16-bit memory operations we can do with H and L as a 16-bit register that we can't do with a regular 8-bit register. And one of those is using it as an indirect register like this. So what this is saying is take the memory value in HL here, which is pointing at 9900, which is our first line of tiles here. That's my stream alert. It's fine, we're already streaming. And load the value of the A register into the memory at that address. So this line of tiles is in memory at the address 9900. So we're going to load the value of A, which is currently 0 because we just cleared it with XOR. Put it into that memory address, 9900. And then this I here means increment. So take the value in HL and add 1 to it. So the first time this runs, it's going to load A, which is 0, into the memory at address 9900. And then it's going to increment this number by 1. So the next time we run this command, it'll be 9901. So if we loop this line 40 times, then we will run from 9900 to 9940, doing this operation every time, which is what we want. We want to write 0 to every single tile in this list, in this row, for 40 tiles, 64 tiles worth. Yeah. So we do that, and then we're gonna decrement B. So we start off saying we're gonna copy 64 tiles. So we clear one tile, we drop this from 64 to 63, and then if B is 0, or really if it's not 0, if this counter representing how many tiles we have to copy left goes from 64, 63, 62, if it's not 0 yet, then we still have more tiles to clear. So we will jump back to this line if B is not 0. and do the same thing. We clear out the next tile, decrement B, check if it's 0, repeat. So I think that should work. And sure enough, there we go. I love that I just have to hit reload and it reloads. So now, no more Nintendo logo. We just have a blank screen, which is what we wanted. So that's exciting. Okay. So now we got our blank screen, we got all of our tiles still in memory here. So let's start drawing our snake. Oh man, I've forgotten how to do this. Okay, RAM values. Is it work RAM 0? I think so. Okay. And then let's say snake X. Is 1 byte. Do I have to explicitly end sections? I don't think so. So we've got our X coordinate in tiles of where the snake is, and our Y coordinate in tiles of where the snake is, where the head of the snake is, I should say. At first that'll just be 0, 0. So we can draw our snake head at that tile position. So if we look at our background map here, tile 0, 0, that is at 9800. So let's see, I need to remember how to do the math of this. Okay. Let me just write it in pseudocode first. So we start there, and then we add plus snake head X. And I think, yeah, it's 32 for each additional one. Yeah. So that's the calculation we need to do to set the tile that we want. So let's put that value in HL. And the bottom of the screen isn't going to fit in just 2 bytes. So I think we can do a 16-bit addition here. Snakehead Y is always going to be up to 17. Interesting. I guess so, yeah, because that's 144 divided by 8, 18. So there are 18 tiles vertically. That's an awkward number. So So we need to do this operation, but on the registers. How do I do times 32? I can do a left shift, but can I do that with carry into another register? And look at the instruction list. So shift left. So I can do 4 left shifts, I think, to get to times 16. So let's say thanks for the Hydra Yazoo. So A is now a snake head, Y, and I want it to be times 32. So shifting left. Is it just SL? I feel like there's a way to do this without. Or is it just rotate left A? That's right, there's weird stuff about there not being that many instructions. Was it opcode table? Is this the one? No. Kind of. There's all the operations that the Game Boy CPU can do, by the way. Nothing to say, we want to show that you're still here. I appreciate it, Yazoo. I know this isn't the most engaging type of stream content, but it is something I enjoy doing. So, I appreciate you being here anyway. Even if it's not the most exciting for you. Doesn't even have SIMD instructions. Nope! It has an extremely limited form of pipelining in the sense that it does a prefetch of the next instruction at the end of each instruction. But that is the extent of the complexities of this console. Okay. Yeah, so there's rotate left. Through carry, rotate left, rotate right. There's not a shift left instruction that doesn't involve doing all of these. Okay, so this is just going to be a slow operation, but it's fine. There's probably a better way to do this, but I don't know what it would be. I'm glad ChatGPT understands what this does. So every time we shift left, we are effectively multiplying by 2. That'd be what I went to give water, so I missed the context. No, understandable. In order to calculate from this where the snake's head tile should be in the tile map, I'm having to calculate this equation. And I'm trying to figure out how to do this times 32 plus other value within the instruction set of the Game Boy, because it doesn't have 16-bit addition or multiplication directly. Okay, so Snakehead Y needs to be able to hold up to 18, so that means it has to be a 6-bit value. A bit shift will carry to another register. Yeah, not directly, but there should be another command that lets us shift in the carry flag into another register. So that's what we're gonna have to do. Okay. So this is a not 32-bit, 5-bit value. So if we shift her once, then it's in the 6, 7, 8 bits. So if we shift it any more than this, we will start losing data. The shift left A, push it into the carry flag. The high bit. Let's see. Yes, okay, so carry flag is set in the high bit. So 5 bits, 6 bits, 7 bits, 8 bits. So this next time we shift, the high bit of A is going to get pushed into the carry flag. So now we need to shift the carry flag into another register. I don't know which one that would be, but I'll figure it out. Must be one of the rotates. Okay, rotate register A left through the carry flag. That sounds right. So this will push the carry flag into bit 0. RLA. Snackhead. So I think that should be right. So theoretically that will put this 32-bit value times 32 spread across A and B registers. Yeah, now RLA is rotate left. Oh, that's only register A. Whoops. I think for the other registers, just RL. Yeah, same idea though. So that'll shift the B register and move the carry flag into bit 0. Which is what we want. So B will be zeroed out, and then we shift the carry flag from this, which would be where A overflows. Shifts that extra bit into B. And I'm gonna have to redo this anyway, because I think we want to do this with one of the 8-bit or 16-bit pseudo registers. So I think we actually want to do BC. Yeah, so B is the high register, this will be C. Can we do this, or does it have to be A? Okay, we can directly load, not indirect. Uh, yeah, there's no indirect load for B, just A. So we'll need to load snakehead Y into A. Then copy A into C. Yeah, so I think that works. So now we've got this portion spread across BC. And now we need to add snakehead X with carry here, so yeah, and ChatGPT knows what's up. So we're gonna add A to C. Can we? Right now, because this is how accumulators work. Yep. ChatGPT, like, I got you. Yep, exactly. Alright, so we're gonna add snakehead X to C, and that could overflow. So we'll need to also add with carry to B. So first we copy the value into C. And then what are we adding with carry? Just 0, I think. Yeah, so we add the carry flag into A, and we copy A back to B. There's got to be a more efficient way to do this, but I think this gets us there. We'll find out. If I was doing sprites, this would be easier, but I need to be able to draw tiles because there are. If we want the snakes to be able to fill the screen, we cannot use sprites. The Game Boy only can handle 10 sprites at a time. So we're gonna need something like this. Okay. So now BC is our offset. Snakehead X plus snakehead Y times 32. So now I think we just add HL and BC together. Yeah. Nice. Okay. And then the tile we want to draw for the snakehead is tile number 2. And we set the tile ID to the address at HL. Okay, I think that works. Let's find out. Build error. I'm doing something wrong. RAM values cannot contain code or data. That's right, I don't know the syntax for this. Let me look it up real quick. Variables? No. RAM codes? No, I don't need RAM code specifically. This isn't the best instructions. Let's see. Allocating space in RAM, that's what I'm looking for. DS, okay. Or DB with no arguments. That was my problem. I put a 0 here. Reading uninitialized work RAM. Okay, that sounds right. So Snakehead X and Snakehead Y don't have any values yet, which is true. Okay, try that again. There's a breakpoint. Why is it hitting a breakpoint? So again, accessible VRAM. Now, so at this point, we can't access VRAM anymore? Isn't the assembly of 16-bit operations? Sort of. It has a few. You can actually see them all here. So we can increment the pseudo 16-bit registers, or decrement them. We can add HL and any of the other registers together. And that's basically it. It's a little bit limited. Use HL to store your number. Simplify the operations. That's true. Instead of BNC. Well, currently HL is holding this number, but no, I think it would be the same still. I guess theoretically this could be a 8-bit edition at the end instead of a 16-bit edition at the 16-bit edition, since it's only has a value in the upper register. Man, we wait for the V-blink right here and it's already invalidated. I can't be right. At HLR16. No, I don't see an operation for that. Well, or there is for 16-bit registers, but it's not constant. R16 is a 16-bit register name. That's what that stands for. Yeah. Yeah, in this case, R16 is 16-bit register. So that's those other BCD, HLSPs. I see what you're getting at, though. If that was an instruction, that would work. Huh. So my wait for interrupts must not be working properly. So that just does a halt. Until V blank. Is any other interrupt enabled? No, just V blank. Yeah, the difference 16-bit register of HL is the one that has 16-bit arithmetic operations. Yeah. But there's not a lot that directly operates on HL still. So you see all these ones that are in the brackets. That is operating on the memory at the address that HL contains, rather than operating on the HL register itself. Which is confusing. Pretty good at not backseating games, but apparently programming is a weakness. Now, I appreciate it. I am very much a novice at Game Boy programming. So I appreciate someone calling stuff out. So I miss stuff, for sure. Okay. So it's saying that we're already, like, in the middle of the next line, that V-Blink is already over by the time we get here. Which is possible, but if so, that's crazy. And just this batch of instructions burned through our entire V-Blink buffer. Let me add a breakpoint here. I defined that right. Yeah, debug break. There we go, we programmed to take a course in embedded programming. So you get the idea. LY is 0 here. Why is LY 0 when we're waiting for the interrupt? I was trying to be smart and having the Game Boy pause until the interrupt happens. There's an HL rotate instruction so you can avoid the carry logic. I think those operate on the memory address at HL, not the HL register as a 16-bit register. No, you're good. You're good. Yeah, the Game Boy doesn't have 60. In fact, the Game Boy doesn't even technically have 8-bit. Doesn't even have 8-bit arithmetic. It has 4-bit arithmetic, and it just does 2 ALU operations in parallel to do 8-bit addition as a 4-bit ALU. So it's a little bit limited, yeah. Okay, but something's going wrong here. So theoretically, I'm setting it so that only the V-blank handler is on. And it does seem to be checked off there. So now when we halt, it should only resume when V-blank happens. I need to look at the instructions. Not the instructions, the documentation. So under here, yes, halt. Resolution that pauses the CPU when executed. CPU will wake up as soon as an interrupt is pending, when IE and IF is non-zero, which is the case. Only IME is set? Yes, it should be. Is that in here somewhere? I don't actually know what that means. I just have a dot here. Do I never actually enable interrupts? Is that the problem? Okay, okay, that fixed it. Okay, okay, finally. I just did a dumb. You can't wait for a V-Bling interrupt when you haven't enabled interrupts. That would make a difference. I rebuild without the breakpoint. There we go. Okay, so we got our snakehead on screen. All right, now is the math correct if we reposition the snakehead elsewhere? If we say 5. Where is it? It is off screen, okay. That is incorrect. Dang it. So our algorithm is not correct somewhere. So the snakehead should be at 5, 5. 0, 1, 2, 3, 4, 5. So it should be like right here on the map, but it said it's over here, which means it's not far enough down. So I need to do another shift. Oh, yes. Right. Wait. Well, it's 5-bit value, so 6 bits, 7 bits, 8 bits. So after this shift, carry happens. So I think we need to do this twice. Yeah, so then we shift to 32. And B will have the highest 2 bits of that. There we go. Okay, now it's in the right place. Nice. So now we can position the snakehead anywhere we want on the Game Boy screen. Move to 6. Can move them into different places. 6 and 3. Boom. Beautiful. Maybe want to do my own. It's a really cool, like, puzzle, you know? You got a very limited toolbox of operators to work with, of instructions, and you gotta figure out how to string them together to get the data into the registers and memory addresses that you want them to be at. It's pretty fun. Okay, so we can draw a snakehead. Literally human resource machine, exactly. Pretty much. A little bit less gamified, but same idea. Okay, so now we've got every frame we are drawing the snake head to a certain location. So now the next thing would be to move the snake in a direction. Literally making a game. I am. That's true. Okay, so we got the snake's position. So let's also define the directions that it's moving in. I don't know why it always wants to put an end there. I don't think it's required to do so. So I think for the sake of simplicity, let's see. And then how many tiles are there? There's 16, 17, 18, 19, 20, right? 160 pixels wide, so it goes from 0 to 19 in decimal numbers. Yeah, it's just -1, right, isn't it? Because that's 144 plus 16 would be 160. So I think it's that. So 15, 16, 17. Yeah. So those are those values. So we'll need to check to see if the snake ever leaves that range, and if so, kill it. We'll get there when we get there. So then move X, that's going to be whether it is moving left or right or not at all. So we'll do right is +1, left is FF, which is -1 in 8-bit math. Same with move Y. So that'll track what direction the snake is moving in. We'll set those two and handle them individually. So let's say the snake is moving downward. So I'll put a 1 in snake move Y. And we'll see if we can code that in. So let's draw it first, and then we'll do other logic afterwards for the next frame, since we want to make sure that happens during VBlank if possible. Yeah, so let's get the current value of the horizontal movement, and then we can check to see if it's 0 or not. So if it is 0, then we can skip all our movement code, but if it's not 0, then we do have to actually do something. Let's store horizontal movement in B. Yeah. And then we can get the head value in A. Add them together. And for now, let's just keep moving. We'll deal with boundary checks later, because that'll trigger game over. So I'll add the two together, and then we'll write it back to snakehead X. Now we do the same thing with Y. Check to see if it's not 0. ChatGPT gets it. Cool. So all we're doing is taking these move values and adding them to the head values. Simple enough. And nothing's happening. So you're putting values in there. Snake move Y should be 1. To compare 0 and 1, they should not be the same. So then it should load B. You can add a breakpoint here. So the B register does have 1 in it. So Snake and Y is 1. We add it to A. We put head A back in that variable. And that gets used on the next frame to draw the tile. Yeah, this looks correct. It's going up even. I see that the A register is increasing here. So why isn't it drawing the tile at the new location? I can even see HL increasing there every time I step. Is there something I'm not resetting properly, maybe? This gets reset every time. Reset B, reset C, reset A. So all those variables are reset, so that should matter. B and A are reset here. Curious. We are looping, yes? Add a breakpoint in here somewhere. Never getting to this breakpoint, actually. That's concerning. Or is that a 1E? Oh, it is here. Yeah, I can see the values increasing. What's up with that? Oh, wait. Wait. Is it because it's making a full loop every frame so it looks like it's not moving? Something weird like that? Could be. Yeah, because it does flip around in the time it's taken to do that. And can I directly edit these? Yes. And it's updating every frame. Curious. Yeah, so it's getting here. It's updating Snakehead. Actually, let me add a breakpoint here. And see if that value is changing at all. It is. A is increasing here. So is C. Yeah. Snakehead Y is increasing. If I change the initial value, does it still change it? It does. Why is it only working the first time? That's confusing. Can add, for example, add HL to HL and that would be equivalent to a left shift. Actually, that's true. Adding a number to itself is the same as multiplying by 2. That's a good point. That could potentially significantly simplify this, actually. Can I do block comments? I don't think so. Anyway, I just needed an event. Cool. Now that makes sense. What's that to do for that? So is the address that we're writing the tile to changing? It is. Huh. We are writing to video memory. (9E66). That should be... Okay, well that's off the field. Actually, yeah, where is that value going? It's just going up and up and up. Huh. Is that just looping between 9F and 9C? It is. So it's trying to draw it off screen. But only after the first time. So something in my math is causing an overflow here. Let me try replacing this and see if that makes a difference. Oh cool, I can do block commenting here, excellent. Okay, so we want to load snakehead Y into A and load it into L. Oh wow, haven't seen many of those in a while. Good job, Saribot. Okay, so that gives us a 32-bit multiplication. Nice. It's probably technically slightly less cycle efficient, but I don't care. Now we just add snakehead X to it, easy enough. So snakehead X is a 5-bit value, so we can just load that into maybe C. Keep taking snack. And then B, which is the high byte. Can I do N8? Yeah, okay. So then I can load 98 in there. Remember to also clear H. Do I want to clear H? Oh, right, yes, yes I do. Thank you. Yes, that would make a difference. Thanks, Sugi. Yeah, so that gets us to this equals that. Boom. Okay. That's a lot shorter. NBC write exception. Okay. But the address it's calculating is way off base. Thanks to the hydrate. Okay, so it's pointing towards all over the place. Okay, am I doing this right? I bet this is getting out of bounds. Okay, let's slow this down. I think that's part of the problem, is it's just happening instantaneously. Every frame. Yeah, let's wrap these around, actually, is what we should do. Let's wrap both these around to 5 bits so they don't break out of containment. They're still freaking out, but that should make a difference. Okay, so where am I going wrong here? So this should be Snakehead X. Snakehead Y, that is a 5-bit value. 6-bit value, 7-bit value, 8-bit value, 9-bit value, 10-bit value. Adds those in. I think this is still correct, so why is this so crazy? XOR H. Add it up here. Oh, wait. But that doesn't do what I think it does. I'm dumb. So actually that's XOR AH. Yeah. But it's not H is 0. You have to explicitly load a value of 0 there. Yep, that would do it. Okay, here we go. Excellent. So the snake now goes vertically down, and then when it reaches 31, it wraps around. Nice. Now I'm sure you could see the obvious problem here. But at least we can get rid of that code. So we can draw the snake head and we can move the snake head. That's perfect to you. Yeah. So the problem is having the head move is fine, but we want to replace where we move with the body if we have spare body segments to drop. Otherwise, we replace it with an empty space. So let's start by just replacing with an empty space. So I wonder if we can turn this into a generic routine here. To just draw a tile. And actually use the call stack. So for now, let me leave that there. But go down here and we'll make a helper function. Probably just we only do inlining in this house. See, normally that is what you're supposed to do. You're supposed to write a macro that will just repeat the instructions in both places. But you also have to worry about running out of ROM space. We only have so many bytes in this cartridge to hold instructions. So sometimes you have to make a trade-off between runtime overhead and now using up all your ROM space. Alrighty, so we have our draw tile function. It's a single tile at the specified position. So let's see, what registers does this use? Clobbers, at the minimum, it's going to clobber HL, because we do that. I don't think we actually use any special functions of the A register here. We just use it as intermediary, so we can potentially skip using A and use something else if we need to. We do clobber BC. By clobber, I mean we use it, so after we call this function, we can't guarantee that whatever value we wanted is still relevant here. Oh, I think we do need to use A for the memory access, but potentially we can pull that out here. So that still leaves DE. So we could say DE will hold tile XY coordinates. A will hold the tile AD. So currently A for this section is holding the Y coordinates. We can replace that with E. And here it's holding the X coordinates. We can replace that with D. Here it's holding the tile ID. We can pass that in directly into the function. There we go. And we replace these with more generic names. There we go. So I think we got our function now. So gonna give until I sense my mouse over it? No. So we're just gonna have to look at the documentation when we call the function later. So now theoretically, instead of all this, we can tile ID, and then X coordinate or the Y coordinate is in E. Use the Y coordinate. So what we want to do is this, but I don't think we can do that. I don't think there's an instruction for that. We're looking for these instructions, which are only available for the A register, naturally. So actually what we need to do is this, copy it into E, copy that into D, call that function. Oh yeah, and then we need to return from the function at the end. That'd be important. Okay, so now theoretically this should do the same as this. And it does. I don't know why I have a breakpoint set there. But there we go. Cool. So it takes a few lines of code to set up the variables for it, but it works. So now what we can do is we can draw the snake head after it moves. So wherever it is now is where it will be. And beforehand, we can clear out where it was previously. Your previous snake head tile. There we go. Now we have a very fast-moving snake head. It is moving one tile every frame, which is approximately 60 tiles a second. So a little bit fast. And probably a little bit difficult to play Snake at that speed. But that works. So we can use the tile of the snake facing downward for this. That's tile number 5. There we go. Although now that I've done that, I want to test to make sure that the other directions also work. It's raining snakes. That's true. So say we're moving up instead. That works. We're moving right. That works. And if we're moving left, that works. Okay, nice. So our movement code does in fact work as expected. And then theoretically, once we get around to adding button input, we can just change the move X and move Y variables based on the directions that the player is pressing. And the snake will just move the way it's supposed to. Alright, so let's find a way to slow down here. I think we have to change this to a jump. I have a feeling we're about to hit the limit of a short range jump here. Alright, so I think the best way to slow down the snake movement is to tell it to wait a certain number of frames before moving to the next tile. So we can say, wait 5 tiles and then move a tile. Or wait 5 frames and then move a tile, and then wait 5 more frames. And if we want the game to be slower, we just tell it to wait longer. Wait a larger number of frames. And if we want it to go faster, we tell it to wait a fewer number of frames. If it's waiting 0 frames, it's going to look like this. So let's add some variables for that. I'll say like snake speed countdown. And then also snake's speed is kind of inaccurate. It's more of a slowdown. Snake move. I guess it's like a frequency. A period. And I guess that works. Yeah, that makes sense. So the snake move frequency will be how many frames to wait, and the move countdown will be how many frames we've already waited until the next time we move. So So let's give those some default values. So let's say waiting every 10 frames before we move. So that would be 6 tiles a second, which is still pretty fast. So we are going to first add that value. Lower by 1. And check to see if it's 0. And if it is not 0, if we're still counting down, then we will go to the next frame, the next update loop. Now, if it is 0, then we're ready to update. So now we can reset the countdown to the frequency. There we go. ChatGPT understands what's up. There we go. That looks much more playable. Still might even be a little bit fast, but there we go. Now obviously we can see that this does make the movement look a little bit jank. So a future improvement would be to use a sprite instead of a tile to create the illusion that the snake is moving seamlessly from one tile to the next. Just have a sprite that moves those couple of pixels every frame. But for now, we're just worried about the gameplay, so we'll leave that alone for now. So we got a snake moving. Very cool. Alright, now let's see if we can control the snake. So let's look at the code for reading joypad input. So, if I ever use your Gameboy thing, do I need to lay out a magnifying glass, or is that only for the actual console? Only for the actual console. You could also play on a Game Boy that has a backlight, like the Game Boy SP. But the emulator, obviously, doesn't have the same issues that the physical console did. But you're right, it was the thing where the screen is very dim and low contrast, so it's hard to see. Yeah, the screen magnifier things, exactly. Perfect, I already knew that I wanted to read input. Remember, needing those things during road trips is awful and you love them. And there's a certain amount of nostalgia for that, right? Even if it was awkward at the time. Okay, so we need to tell it that we want to read the D-pad. And see if there's any predefined fields for this. It was so bad and you miss it. Yeah. Formative years and all that. Or just a read and joypad info, that's the one. And we want to get the D-pad. Then hardware. Yeah, RP1. That works. And then we read the values. And then for a silly reason, they actually read the values 4 times because it takes a little bit for the joypad to actually read the right values out. Just to make sure exactly. Most programs read from the port several times in a row. The first reads are used as a short delay, allowing the inputs to stabilize, and only the value from the last read is actually used. So people noticed that when they read the value, it wasn't always correct, so they just repeated the code multiple times. Hardware interrupts. So those are signals generated by outside chips that can trigger the Game Boy to react. I read as a Jeopardy answer. Sorry, yes. That was not a question, that was the statement. My apologies. I figured that you should have known that, yeah. Joke is really hard to make over text, and unfortunately, yeah, it does require a certain amount of tone of voice. But oh well. It is a good joke, I just didn't get it immediately. Yeah, so this is debouncing the pins, effectively. Alright, so anyway, so we've got our input in our A register now. So now I want to check each individual bit. And if it's not read, then we jump to the next one. So let's start with the right button. This would be R1F0. Yeah. And we want to check if it's set. So this would be and, I think. So check to see if that bit is set. Yes. And if it is set, then that button is not held down. So we can skip. And what is that? Is that the right? This is no input right. So if we are inputting right, then we want to write 1 to snake move X. And we want to load 0 into snake move Y. Actually, we can do this with just a increment A. So it'll be 0, we load 0 into Y, and then increment X, and move 1 into X. So now we are moving positive on the X-axis, not on the Y-axis, which is what happens when you input the right button. Does that make sense? Okay, and then you want to skip ahead to when we're done with the input section. Yeah, I think that works. So it's basically a switch statement, but or an if-else chain, but decomposed into raw jumps, which is fun. Okay, so now we get the left input. Yep, you get the idea. So you write 0 to y again, and then we decrement a, so it'll be -1, which will be 55 ff. Right, that's negative x. That makes sense. It's funny that in high-level languages, go-to statements are a big no-no, but in assembly, it's the only way to do logic. Yep. The processor only does go-tos. That is the only form of branching. I guess technically calls and returns, which are just go-tos, but with the stack operation to push or pull the address first. It's the same idea. But they are a huge pain to optimize. And someone recently let FF and online games means forfeit, and that's all you understand every time I say it. Understandable. Okay, is that down? No, it's up. Okay, and I got it all wrong, of course. Yeah, so bit 2 is up. So first we reset A. And then if we are moving up, then we reset the X movement to 0. Yeah, you got it. Good job, ChatGPT. And then down is the same thing. Reset the X movement, increase the Y movement. Okay. So that's a lot of work, but I think basically that gives us movement. Let's see. I can't tell where it went and wrapped around. Okay, I can move right. It is automatically moving left regardless. But I can force right if I press the button. Okay, so if the right button is not held, then we jump here. Check if the left button is held. If the left button is not held, we jump down. That makes sense. Is there anything else I have to do here? I don't think so. Oh, these are backwards. If this bit is 0, then buttons can be read from the lower nibble. So I want to set the button 1. That's confusing. Oh wait, no, I think they've done that already. So bit 5 is set, which is the buttons 1, yeah. So we cancel all buttons to get the D-pad, get those values. So why is it always moving left? That means that if any of them are happening, it would be this one. No input right. And we do exit out after each case. Is this incorrect? I really wish that worked. Yeah, so we get the lower bit and we check to see if it's set in both. Yeah, so if this bit exists and it is currently not held, yeah, so the bitwise AND will be 0 if it is 0 in either of these values. It is not 0 here by definition. Am I dumb? I mean, probably. It seems pretty straightforward. Yeah, sure enough, I'm always moving left, unless I overwrite it. Is there anything else setting these values? No, just in here. If I make sure they're both set to 0. And start, no, it's still moving. Okay, let's set a breakpoint then. Okay, so I'm looking for if 106 through 109. So we reset A to 0, set vertical movement to 0. So that has complete. That's rude. Yeah, and then increment A, so now it's 1. So 0, then 1. Save that to movement X. Move X, which should be moving right. Which is correct there. I can move right here. So this would mean it's 0. So this evaluates to 0 when I'm holding the right key, and it seems to set all the other values as expected. If it is not 0, then it jumps here. It compares those bits. So it should be this second bit here. P1, F1, yep. And for some reason it thinks this is always 0. Oh, wait. Right, duh. Because A is still the result of the AND here. That's why. So it's not the input anymore. I guess I can back up the input value into B. And just swap those around. That's fine. That would do it. Okay. Nice, I now have 4 directional movement. Okay, something I do notice is it only takes effect if you are moving in that direction on that frame, which makes sense because we're skipping all of this processing otherwise. To make it more responsive, I think what I want to do is I want this input check to happen before we do the countdown check. So it just immediately changes your movement direction, even if it's mid-frame. But you don't actually move until the countdown finishes. Yeah, so now you can kind of preemptively change the direction a few frames ahead of time. That feels nicer. I keep saying snack. I don't know if the snake is a particularly snacky thing. Cool. Something else we could do is we could have that also affect, which... I'll change it to a gummy worm. Could be. We don't really have the right colors for that on the Game Boy. And I could change the direction that the head is showing. Right now we're hard coding it to tile 5, which is the downward facing tile, but we could do a little bit of logic here to display the head in the direction that it's moving in. So let's see. What's the best way to do that? Is there any fancy tricks we can do here? We can just do a bunch of jumps, that's fine. So currently, we're not using B or C for this section. Or I could set it up here even. That might be simplest even. Let's take move dir. Right, left, up, down. You can just use that as the tile number. So we got here right, left, up, and down in order. So we can just add that number to our sprite number to get the head direction. And we just need to set that value here. So if we're moving right, then it's 0. Yeah, so we're moving right. If we're moving left, then it's 1. I'm just going to do this explicit. Might be kind of confusing otherwise, even if it's going to take a few more bytes. So I'll just copy and paste this a few times. So dir is 1 if we're moving left. If we're moving up, and it's 2. And if we are moving down, then it is 3. Cool. Simple enough. So then we'll load in the move direction, and then we need to offset it by 2 to get the right tile number. And we get an error. Oh, I have not set snake move deer to a placeholder value. That makes sense. So let's just store A there to reset it to 0. Load all those registers. There we go. Okay, left and right are backwards. But that is the idea. And now we can just fix in the tile sheet. There we go. Oops. Did not take effect. There we go. Okay, we can now pilot a snake head around. It's not exactly, you know, the full game yet, but we're getting there. Snake 01, exactly. Okay. So now this part is pretty simple. If we want to leave the body afterwards, we can still use the direction value that we just got. Actually, we can even leave it like that. That might be fine even. So right now, when we move, we are clearing out the snake head. We're drawing 0 there. But instead, we can do it based on the direction. So we get the direction, and currently that is 0 for right, 1 for left, 2 up, 3 for down. But we actually use the same tile for left and right and the same tile for up and down. So when this is 0 or 1, we want to use the first tile, and when it's 2 or 3, we want to use the second tile. There's an easy way to do that. We just only care about the second bit in this value, because that determines whether it's up and down or not. So we'll just Shift A to the right. Let's see if there's a good opcode for that. What does RRA do? Okay, it carries over the carry flag. I don't know what that'll be set to at this point. And this will rotate the 0th bit up to the 7th bit. We don't want that either. Alright, so we'll just do an arithmetic shift right on A. Alright, and we need to add 2 to it. In the big sleepy sea lurk, already, no worries. We're not too, what is this, tile number 6? There we go! Our snake now is a body. And obviously the corners aren't quite right, but we're getting there. We'll need to add special tile handling for the corners specifically. but that'll require more work. Nice. Cool. All right. Among Us. Possibly. Okay. So then something we can do is we can decide whether to draw a body tile or a blank tile based on if we've eaten a fruit this turn. So let's add some more variables for current length. And max length, yeah. Our current max. 'Cause I guess that increases when we pick up a fruit. That works, fair enough. Okay. So we'll just go ahead and do the math for that real quick. So we'll load the current length, and then we'll compare it to the max length. And if they are not the same, then we want to draw the body like this. If they are the same, then we want to clear the tile, I think. No, actually, that's totally incorrect. It's too early for that. We don't have the body being drawn yet. I'll leave those variables for now. But in practice, we are always going to draw a body segment behind the head, for simplicity's sake. What we want to do is we want to start making the tail disappear when we get to the max length. But that is going to require some extra work. What time is it? 7:15. Been streaming for like 2.5 hours. I'm definitely starting to get a bit tired, but I can keep going for a bit longer. So let's see. Let's start tracking the body. So theoretically, in the worst case, how long can our body get? Let's see. So the number of tiles that can fit on screen is 20 times 18. 360 tiles. So we need to be able to hold up to 360 unless we cheat and limit it to 255. But I figure you want to theoretically allow people to fill up the entire screen. So these need to be 2-bit values, actually. Are we still doing that? Yeah, that's fine. Okay. Yeah, so now we need a section for the snake body coordinates. And I think I can insert that. Snake body, we'll just call it that. And we're going to keep a circular buffer of body tiles. So when we move, we will get rid of the body segment at the end and add a new segment where the head previously was. So this needs to be a number of bytes equal to 360, yeah, times 2. That comment is incorrect. 360, 720. Yeah. Okay. So we got our body. Head and tail, is that too repetitive here? I don't know. Okay, cool. So we're gonna have this block of data to hold all of the snake body segments. And then this will track where that block our current head is and where the current tail is. The head will always be head of the tail, and head minus tail is the current length. And we'll keep these because that is still relevant. Keep those separately. There's an awkward number to clear. That's fine though. Okay. The game has limitations. There's an actual limit to the snake size, or just until there's no more space. We could handle it however we want to. But I'm thinking I'm going to limit it to just the tiles that are visible on screen, so no scrolling. And I don't think, unless we did something horribly wrong, that we'd run out of memory completely on the Game Boy's limitations. But theoretically, we could have coded it in a way that we can't use all of the tiles, that it will start like running out of memory before then. But we can also code it to get around that. So I think that's what we're gonna do. I feel like it's a thing with snakes to want to fill up the entire screen. So we might as well. And you like the Zone Zero OST? Too bad it's nice to get anywhere close to that. It's never been your goal. Understandable. Okay, so we went to clear previous snake tail. So let's get access to the current tail. And then loading the increment is just for the A register, I think. Yeah. So we get the X value there. And then X value is stored in D, yep. I guess we could swap these around. Simple enough. And then we want to clear out A. And that's a 2-bit value. Can I... I want this to point to the value at this address. So this needs to be like that, but that's not a thing, I don't think. No, it's just a thing with the A register. So I set this to the pointer. BCD. So I need to use BC here. And we can use BC here. Does that work? No, it has to be HL. Dang it. Okay. Oh, we can. We can load into A with BC. Yeah, okay. Load ABC. ABC. So read the pointer at that pointer. And then we read the pointer at that pointer. And now we need to write it back. Can we do that with ink? We can do that in one place. Okay. Yeah, this would be a lot easier if we couldn't fill the entire screen with the snake body. Okay, so theoretically, if we did that, we'd have to drop down to 8 by 8, I think. No, 16 by 16. Which is losing 4 tiles horizontally and 2 tiles vertically. That's not that unreasonable. That's still a pretty big playing field. Okay, let's do that. I'm gonna shrink the playing field a little bit because it's gonna make the operations on the math a lot easier. How long would this thing need to be to crash a Game Boy? So, assuming we allowed it to just continue spreading forever. It would be until it overflowed in the next memory section. Which, let's see. We have 8 kilobytes of RAM. So that'd be 8 times 24. So the snake could be 8,192 segments long, theoretically. Probably a little bit less than that since we're holding space for other values, but if we went with that approach, yep. Pretty friggin' long. But we're not gonna do that. We're gonna artificially limit its value to much lower than that. Oh, right. But we need to have 2 bytes. One for the X coordinates, one for the Y coordinates. We can do 2 separate buffers. Okay, that should work. And I want to round these out for convenience. I don't remember the syntax for that, but it's in here somewhere. Alignment. Lower bits equal to offset. Got it. Line 8. We're throwing errors, very good. Yeah, that's right, because I changed that logic. So it's no longer 5-bit value, this is now 4-bit value. And does that change this math at all? I don't think so. I think we still need to do the multiply by 32. Yeah. Okay. So now this is a little bit simpler. So we want to say B is the high byte of snake body X. And then C is snake body tail. And grab the X coordinate from there. Is there a way to do this faster? Not really. Okay, cool. And then we can replace B with snake body Y. Cool. I think that should work. Okay, still doesn't like this. We're not clearing out the snake body, that's why. Okay. Current length is 0, max length is 0, head and tail are both 0. Now we need to clear out snake body buffers. Yeah. Clear out that. Decrease B. Loop while not 0. Simple enough. Only for X, and then for Y, it's pretty similar. What is this you're trying to add? Don't do that. I just want the loop. Cool. Okay, so that was a lot of stuff that didn't appear to do anything yet, but we're getting there. So now theoretically we'll be able to clear out the tail when we move, but we haven't done that yet because we don't have a tail yet. Let's say the tail can be up to 4 tiles long at first. So, if we are at our limit, then we want to clear the previous tail tile. Current length compared to the max length. Can I do that? No, I can compare to the raw value. No, bro, that works. So apparently we're never wiping the tail because we're never getting longer, but that check will allow us to do that now. So if we're at our max length, then clear the previous tail, otherwise skip. So I guess we're visually clearing out the previous tail tile, and then we also need to advance the tail length. So snake body tail needs to increment. I don't have to do that. That's going to happen implicitly. Cool. Okay. And then when we move, we add the new position. Can I write to BC directly? Yes. Okay, which means I need BC to be something here. Yeah, that works. Cool. Let's see if that works. Okay, it's not resetting things yet, but that should be doing things. Oh yeah, now we're no longer fitting into the full field. Which is fine. Oh yeah, these are just 4-bit values. So actually we don't even need separate arrays for these. That makes things even simpler. You can pack them into both and just swap the nibbles around. Okay. So if we're at our max length, then we do erase the tail. Yeah. That makes sense. Okay. So now D needs to be the lower nibble. And then E needs to be the high nibble. So then I'll swap the nibbles around. Let me just get the lower bits and assign that. Cool. That should work. And then when we add the new head, we will take the current head value. Yeah, that'll work. And then we grab the current head value. We need to store this somewhere. You put it in D temporarily. Duh. Okay. And then load A into Y, we swap the nibbles in A. And we do a logical OR of A and D. And write them both to BC. Yeah, okay. That should work. A here is, yeah, the new head. Thanks to the hydrate. Okay. So what is the tail then? So actually this should be running. So why doesn't it? I'm gonna breakpoint in to see what it's doing. It's never hitting it. Oh, because they don't start out equal, that's right. Okay. So thinking about this, so snake's current length is 0. Current max length is 4. If our length is not the max length, then we want to grow. Yeah, so this happens if we don't grow. So if we're not growing, then we are eliminating the tail end of the snake. If we are growing, then we do logic. I wonder if I can swap these around and then have the right value there. Say it currently has the current length. So just increase it. And then we don't change the tail. Yeah. Simple enough. Okay, well, that's progress. Currently, we are not adding any segments. We're not growing at all, but it is cleaning up the tail as we're traveling. So that's progress. Okay, so if max length is not the current length, that's backwards, yeah. If our max length is the current length, then we don't grow. If it is different, then we grow. Oh, look at that. There we go. We actually have a limit to the length of our snake. Nice. Okay, and I imagine you can guess what comes next after that. Now we need a way to get longer. Looks like we started a little bit short. Let's start at 3 segments. Why does Snake go to the other side before reaching the wall? So that's because I changed the logic so that the snake's position can only be a number between 0 and 15. Before it was a number between 0 and like 30, which was, or 20, which was the full length of the screen. And the reason for that is if this is between 0 and 15, it only takes 4 bits to hold that instead of 5. And we can put 2 4-bit values into 1 8-bit value. But if we have 2 5-bit values, we need more than 1 8-bit value to hold it, which makes the code more complicated. So I'm making it so that it wraps around at tile 15 instead of continuing to go further. What I'd probably do is I'd probably like offset it a bit and change like the color of the border to make it feel like there's like a boundary around the playing field instead of just teleporting to the other side like that. But it does make the code significantly simpler. So, you know. And the reason it wraps around is actually just because of how math works at the computer level. When you reach the maximum number that something can be, and you add more to it, it'll just wrap around to the next value that it can hold. So since this can hold between 0 and 15, if it gets to 15 and then you try to add one more, it will wrap around back to 0. There's only so many zeros and ones, and if you run out of ones and zeros, you just have to reset everything back to 0 and do it again. That's just how computers work. But yeah. Cool. So let's add the apple. Or fruit. So this gets a little bit tricky, and you'll see why later. But let's start with something simple. So let's just set this to a predetermined location. So let's say it's at like 9 and 7, sure. No, 13. Okay, so we got our fruit. And then we want to draw where the fruit is. And it's already auto-filling it. It knows how to draw tiles at this point. Our fruit tile is number 8. Okay, there we go. We got a fruit. And we passed through it. We don't have collision checking yet. But we got a fruit rendering now. Okay, so now what I can do is check to see after we've moved the snake if we are on top of the fruit. So we get our snake head and we compare it to the fruit's position. And if it's the same, then we continue. Otherwise, if it's not the same, then we skip. Okay, so if it is the same, then we can eat the fruit. So that'll be the current snake length. We'll increase that. Actually, we want to increase the max length is what we want to do. Yeah. And then for now, we'll just leave it there, test that out. Oh, there's an error. Line 225? What? Oh. Starting HL, that's right. Okay. I'll store that. Can't do that directly. We're gonna add another step. Okay, there we go. So now currently we have 3 segments. And now we have 4. Now we have 5. So we're not getting rid of the fruit, but we can eat the fruit now. And get longer. The fruit is just an infinite fruit that never ends. Okay. So here's where it gets tricky. We need to know where to move the fruit to after you've eaten it. And we have to make sure that wherever that is, it's not... so you're just taking really small bites. There you go. That's a good explanation. We have to make sure that wherever that is not on top of one of the snake body parts. So this is going to get tricky. So I think one of the better ways that I've seen of doing this is instead of randomly generating a number, we just have a random order that it checks every available position in, and if it finds one that's free, then it spawns there. So first I want to generate a random table. I'm just going to write some JavaScript code to do that real quick, so that'll be faster. New array of 256 possible values. We get an array of numbers from 0 to 255. Perfect. And now we need to randomly shuffle it. That didn't work. Randomly shuffle array, JavaScript. All right, this one works. So we map it to I and sort value of random. Sort it. Map it back. There we go. We got a random list of numbers. It will cover every possible position from 0 to 255. Never repeating. I'm going to copy all that, copy it into our source code. Rand table. There we go. And it's kind of ugly, but it's fine. And this we need to align. Does that work? I need to look that up. Line 8. Okay, yeah. We saw the different syntax. Okay. So we'll use this to check where to spawn the fruit at. And then we'll check to see if there's any existing segments there, and if there are, then we won't place it there. And we need to reset that to a value. Okay. Okay, so we eat the fruit, increase the max length, and then randomly place the fruit. This is gonna get tricky. So we need to place fruit loop. Fruit loops. Line A. Fruit random index. Yep, and then grab I guess incremented that works. That. And then I want to do that, but we can't do that. That's not a thing. So we need to load B with high value of the random table. And C is current index. Get random value. And get the fruit position. It's not a spawn in a random position. Which I think is fine for now. To do avoid overlapping segments. That works. So now when we grab the fruit, it moves somewhere else. Nice. Okay, so technically we have the playable snake gameplay now. There's no loss condition, and there's no overlap check on the fruit, but we're really close. This is really close to being a fully playable snake game. And there's obviously polish we can do to like make it look smoother. Have the head move gradually instead of jerkily like this. And I mean, you know, not bad. Alright, so we can pass through ourselves and it glitches things out a little bit. Not meant to do that. And of course I'm playing really slowly, but we can speed it up. We're currently taking every 10 frames. We can double that. There we go, a little bit faster paced. So if you just pretend that it's possible to die even though it isn't, it's playable. That's kind of cool. I'm kind of surprised at how much just worked the first attempt or two. I'm expecting to have to spend a lot more time debugging to get to this point. So the basic idea now would be to just have a check to see if the head of the snake is touching any body part of the snake, and if so, die. Get a game over. And then during the fruit spawning, check to see if the fruit is on top of any body segments. And if it is, then spawn it somewhere else. And theoretically, with the way we have it set up, it should be able to do that. Definitely. Oh yeah, and also probably shouldn't be able to turn on top of yourself. That seems reasonable. Next week's Skyrim for N64. That'll be a bit more work. Well, funnily enough, the N64 is closer to a modern processor compared to this, so it's a little bit easier to program for. Obviously, the next step here is to add RPG elements. You gotta be able to like level up and spend your XP to increase your length or your lives. Buy perks. Increase your speed, add a speed boost. So it's kind of funny that it wraps around. Don't forget microtransactions, of course. And then release it on mobile. Exactly. Oh yeah, then we also have to do the corners. So that would be a matter of, instead of always drawing just based on the horizontal or vertical direction, we'd have to check based on what direction the head was going and what direction it's going now. And we can use that to calculate what corner tile to draw. Alright, I died there. Cool. I think I'm probably going to wrap it up there. I'm starting to feel pretty tired, and I still gotta pack up all my computer stuff tonight, so it's ready to go tomorrow. But hey, we have something approaching a playable version of Snake on the Game Boy. I think that's pretty cool. Only took a couple of hours. Thanks for streaming. Good luck on the move. Thank you. I will need the help. I will need the luck. You can see it doesn't know what to do when the segments all overlap like that, which makes sense. There's a good reason normally the game just dies at that point. Alrighty, let's find us a raid target for today. See, anyway, schedule-wise, I want to start streaming again as quick as possible, but it depends on... So I'm going to be at my parents' house for a while until we're able to fully move into the new apartment. So it depends on if their internet supports streaming without like dropping frames and stuff. So I'll have to see. I won't be able to use Ethernet, so it'd have to be on Wi-Fi, which usually adds a lot of frame dropping, but we'll see. So worst case, I won't be able to stream for the next couple of weeks until we move into the new apartment, and then I'll be able to set up an Ethernet connection there and everything. But if I am able to stream from my parents' house, I will. So we'll see. I'll let y'all know next week, probably before Friday, if I'm going to be able to stream the next couple of weeks or not. So might be a short hiatus, might not be. We'll find out. You know what? Screw it. Offline raid to Kitsu. I think that's fair. Alright. Thank you all for being here. Yahazu, Carrick, Sugi, Oshu. Everyone else who's lurking. Appreciate all of you. Kitsu, of course. Can't forget Kitsu. That was the whole point. And Lowell. Can't forget Lowell. Thank you all for being here. Hope you all have a great rest of your weekend. And I will see you all next time. Oh yeah, definitely not streaming Sunday. I will most likely be unpacking that day. Will not have my PC set up yet. We'll see. Damn, I will see y'all when I see y'all.